Welcome back to All This Math. This is Professor Parker, and for today's lesson, after we talk a little bit about South Carolina State University, historically black college in Orangeburg, South Carolina, today's lesson is we're going to do some factoring using the D.O.T.S method. The D.O.T.S method. D.O.T.S is an acronym that some people like to use. It stands for the difference of two squares. The difference of two squares. The difference of two squares. And I'm going to talk a little bit more about that in a moment. Since I have my South Carolina State University sweatshirt on, you see this is the school logo, I believe, or the school motto, I should say. Knowledge, duty, and honor. South Carolina State, founded in 1896. Do some research on the Orangeburg Massacre. If you're not familiar with the Orangeburg Massacre, do some due diligence on the Orangeburg Massacre, which took place, unfortunately, on the campus of South Carolina State University. I want to say, I don't remember the date. It was in the 20th century, probably in like either the 1960s or 1970s, I want to say, but definitely do some research on that. All right. And shout out to the HBCUs. Okay. So now on to the work of factoring using the D.O.T.S method. Now, what is factoring? Factoring is when we're dealing with algebraic expressions, factoring is when you take an expression and you break it down into separate parts, right? So here we have, in number one, we have a binomial. Why is it called a binomial? Because the prefix bi means two, and it's got two terms. Terms are separated by plus signs or minus signs. That's a minus sign. So this is one term, that's another term, for a total of two terms. All right. So first, what you want to do is when you're looking to see if you can factor an expression, you want to see what type of form it's in, right? What does it look like? Is it a binomial? Is it a trinomial? Also, you want to see if it has a greatest common factor. If the expression has a greatest common factor, my suggestion is you always pull the greatest common factor out first, always. The greatest common factor between these two terms is only one. Now, if your greatest common factor is a one, that ain't going to change nothing. So basically, it's like it don't even have a greatest common factor if the greatest common factor is just one, right? So basically, that's a rule. Make sure you write this in your notes. If your GCF is one, then you can basically skip that step. Don't worry about taking the GCF out. But you should always check whenever you want to factor. Whenever you want to factor an expression, always check to see if there's a GCF first. There are a bunch of different methods of factoring. It's like 5 or 6 of them. And as you go through the list, you first should always try to see if there's a GCF. All right. It just makes the work easier. You don't necessarily have to. You can take the GCF out later. But my suggestion is to always take the GCF out first in the beginning of the problem. All right. So this has no real GCF except for one. So therefore, we can move on to see if it falls into this category. Is it in the D.O.T.S format? And it is in the D.O.T.S format because D stands for difference. Difference as in subtraction. When we learned subtraction early on, we learned that the word difference represents the results you get when you subtract things from each other. So this is a difference. If this was a plus sign, and this is a common mistake, so make sure you can notice this too. If you see something like x squared plus 100, remember, it's a difference of two squares. It's not the sum of two squares. This says dots. This don't say sots. That's not what it says. That's not an S. So it must be a difference, all right? Now, of two, right? Two terms, right? It must be two terms. Okay, so it fits that criteria also. Squares, right? Squares meaning perfect squares. Now, x squared is a perfect square. How do I know that? Because it's a variable with an exponent that's an even number. Anytime you got a variable with an even numbered exponent, that is a perfect square, meaning that there's a term that can be multiplied by itself in order to equal that term. In this case, x times x can equal x squared. Or I should say x times x does equal x squared. Same thing with 100, right? Now, don't worry about the negative sign so much. Don't worry about the negative sign. Treat this like, for the purposes of this type of problem, treat this like it's a positive 100. Don't even worry about the negative sign for right now. So 100 is a perfect square, right? Because 10 times 10 equals 100. So make sure you have all your perfect squares memorized, at least from, back in the day, I think I was in 7th grade, we had to memorize the perfect squares from 1 times 1 up to 25 times 25. And I still know them to this day. So shout out to my 7th grade teacher at Roland Park that made us do that, right? So the square root of 100 is 10, right? Because 10 times 10 equals 100, okay? So now that we know it fits the criteria, now what do? How do you factor it? All right, this is how you factor it. First thing you do is you write two sets of parentheses. All right, so it's going to look like this. You're going to have one and another one. They're going to be adjacent to each other like that, or juxtaposed. I like the word juxtaposed. It means adjacent, or it means next to, right? No symbol in between. So that indicates multiplication, right? Now, what goes inside of these parentheses? So what you could do is, if you need to, is put 2 spaces right here and 2 spaces right here. All right? This is probably, arguably, the easiest method of factoring out of the 5 or 6 that are available to us, right? You take the square root of the first term, which is x. We already talked about that. Why is it x? Because x times x equals x squared. You should know your rules of exponents. That would help you with this. If you know your rules of exponents, then you should be good. If you need to brush up or you don't fully understand the rules of exponents, make sure you subscribe to this channel. I have videos on another playlist about the rules of exponents. So you can learn about the rules of exponents, because you need that in order to understand this for real. So we take the square root of x squared, which is x, right? Now, where do you put the x's? You put one x right here, and you put another one right there. There you go. So you put an x here, you put an x here. Now, it's almost like, I don't know, playing hangman, right? Trying to find out where the letters go, right? Now, you look to the 100. You take the square root of 100. What's the square root of 100? It's 10. Where does the 10 go? You put the 10 right here and the 10 right here. Now, you got to put operational symbols in between. Now, with a difference of 2 squares, one of them is going to have a plus sign, meaning one set of parentheses, or one of these binomials is going to have a plus sign. The other one's going to have a minus sign. Do it matter which goes where? No, it don't. Some people like to put the plus sign first, like me. That's kind of like my preference, my usual thing to do. I put the plus sign first and I put the negative sign second, or the minus sign second. But if you wanted to, you could put the minus sign first and the plus sign second. You know, sometimes I might switch it up. I might put the minus sign in the first set of parentheses and the plus sign in the second set of parentheses, right? So this is the final answer. X plus 10 times x minus 10. Now, you have to be careful though, because you will sometimes, right? And I'm gonna do some examples like this on some other videos, right? You'll have a situation where you'll factor it, but then you'll have another difference of 2 squares, right? So for example, if we had a binomial like this, right? And there was a difference of 2 squares and we factored it, right? We pulled out the square roots, put everything where it belongs and all that. We did that. And then let's say you end up with, like, I don't know, x squared plus 49. But then over here, you got x squared minus 49. Then you got to say, oh, hold up. That's another difference of 2 squares. So I got to do that step again. I got to do the whole step again. And I got to break that binomial down. But then in my final answer, I still got to include the first binomial, right? So you're going to end up with 3 binomials in that situation. But you're going to see some examples like that. All right. But just keep that in mind, that you got to check to make sure that you're finished. You got to make sure that your expression is factored completely, meaning you can't factor it no more, right? There's no way that you can't break it down no more. You know what I'm saying? Now, how do I know that this is right? I can check it by doing the FOIL method, right? FOIL, first, outer, inner, last. First, outer, inner, last. I can check it by doing the FOIL method. First, x times x. That's x squared, right? Let me put my check mark. The outers, x times negative 10. That's minus 10x. The inners, 10 times x. That's positive 10x. The last, 10 times negative 10. That's minus 100. I can combine like terms. These are exact opposites, so these cancel out. What am I left with? X squared minus 100. And if we end up with what we started with, that means that our answer is good, right? That means that this is a good answer, all right? And it's factored completely because this is not a difference of 2 squares and there's no GCF or nothing, all right? Let's look at this other example. Y squared minus 64. I'm gonna go through this one quicker because I already broke it down like step by step how to do it and the rationale behind it. So I'm looking at this and I say, okay, it's a binomial, all right? I see a minus sign in between, all right? That's a perfect square, all right? How do I know it's a perfect square? Because my exponent is an even number. Whenever your exponent is an even number, write that down in your notes. Whenever your exponent is an even number, that term is a perfect square. Is this a perfect square? Yes, because I have my perfect squares memorized and I know that 8 times 8 equals 64, all right? You can see that in your multiplication table in the back of your black and white marble notebook as well, all right? So I know this is a difference of 2 squares. Difference meaning it has a subtraction sign in between, right? That's a perfect square and that's a perfect square. If these were not both perfect squares, then we can't factor it like that. In case you had that question, like what if this was a 63? Well, then it's not a difference of 2 squares. It's that simple. Then you can't factor it, right? You just have to leave it. Everything can't be factored. That's something else I should say. Every expression can't be factored. Sometimes your teacher will give you examples just to test your ability to identify factorable expressions and be able to distinguish them from expressions that cannot be factored, right? Because that's a skill in itself. You got to know what can be factored and what can't. I know this can be factored, but I also know if it said y squared minus 63, I wouldn't be able to factor it because the greatest common factor between those is a 1, and it's not a difference of 2 squares, all right? So this is a difference of 2 squares. So whenever I encounter a difference of 2 squares, I can just do this. 2 sets of parentheses, take the square root of the first term, which is y, put a y here and a y here. Take the square root of the second term, which is 8. Put an 8 here and an 8 here. Make one a plus, make one a minus, and we done. That's it. That's all you got to do. So once you get the hang of this, like I said, factoring a difference of 2 squares is probably the easiest of our 5 or 6, I think there's 6 methods of factoring expressions, polynomial expressions. All right. So definitely get some practice. Do some practice with examples that look like this. Ask your teacher, ask your professor, ask whoever, or just go online and do some research on factoring difference of 2 squares, worksheets, pull some up and just go to work. Because you gotta practice these, right? You can't just watch a video and then think you're good, right? You're probably not gonna be good, right? Because 24 hours later, you're probably gonna forget what you learned. But if you practice, it's gonna get into your head. It's gonna sink in. And then you're gonna have muscle memory. And then the next time you see a problem that look like this, you're gonna be like, oh, boom. Take the square root of that, boom, put an x in an x. Take the square root of that, boom, put a 10 in a 10. Make one plus, make one minus. I'm done. And we out. You know, that's what you're gonna be doing. All right. But go get some practice and shout out to South Carolina State University. I'll catch up with you on the next video. Peace.